All right, welcome back, everyone. So today we're going to talk about terrain data sources. So uh, on Tuesday we talked about how we collect terrain data, like what instruments we use, and so today we're going to talk more about where we can actually go out and find data that's already been collected. And so there's two key questions that often come up when we're talking about terrain data specifically, and that is who collects terrain data and where do those data end up? And those are really the kind of key questions. When we're looking for data to do terrain analysis or any kind of GIS analysis, those are the two kind of questions that really kind of drive what data we can find and where we can find it. So we're going to talk about a couple of different sources of data. And the first one will kind of start at like the local scale and work up to the national scale. The first is what I'm calling local sources. So this is things that you might think of like city and county infrastructure projects, so road building or bridge building or park construction. Smaller scale projects done by like the Department of Natural Resources here in Iowa. Small, like more local federal projects. So this could be something, like in Cedar Falls or throughout Iowa, things that the Army Corps of Engineers does. So things like levee construction or dam construction. And for all three of these kind of local sources of data, the big problem is that they're usually just surveyed data done for a very specific purpose. And the trick is that they're usually done by a contractor. So either a contractor who's specifically brought in to do the surveying, or the construction contractor does the surveying. And it's not actually done by the city or the county or the DNR or the Army Corps. The contractors really control those data, and they're done really specifically for those engineering tasks. And so getting a hold of those data can be quite difficult. If you do know of a project that you want some surveying data for, if you can find a project manager contact for that project, you can usually email them and try to get a hold of the data. It's not always a sure thing, but it really is your best bet. So project managers, sometimes if you can get a hold of like county or city kind of public works managers, they might be able to help you, but those data are kind of really hard to find sometimes. Another kind of, I call it a local source, is that university researchers are often collecting a lot of data locally. And so if we are, and we have project data for an area, it may not be like local to the city, but like I've collected data out in Manchester or collected data, at Backbone State Park. Those data, we are usually willing to share those. So if you know of a project, or if somebody mentions a project that a university researcher has done, it's worth getting in touch with them to ask them for those data if you think it'd be helpful for a project. So a step up is at the state level, and this is where we start to get kind of more systematic terrain data collections. And so most state agencies, or most state agency collections of terrain data, usually end up with kind of the state's GIS steward. And in some states, that's a geologic survey. Other states, it's a Department of Natural Resource, like we have here in Iowa. Other states have a specific GIS clearinghouse that's either part of a geologic survey or natural resource department or separate. It just depends. Again, individual project data that these agencies are doing can be hard to find, but statewide collections of data should usually be available online in most states, or at least you should be able to, there should be information on how to access those data online. Again, those can be through things like the GIS's or the state GIS clearinghouse websites. And I'll show you an example here in just a second. Um, a lot of states are actually responsible for collecting LiDAR data on their own. Iowa is a good example. We have statewide LiDAR that was collected in 2009. And then we're actually kind of in the middle of another statewide LiDAR collection that I think was actually completed in 2020, but the data aren't going to be available until later this year. And so if those data are available, they may or may not be downloadable. In Iowa, we actually have a download portal for those data. It's actually run through the geography department and the geotree center that we have in our department. Other states will tell you if it's available, but they may not actually have it downloadable. You may actually have to order that data or, actually drive up to a state office and bring a hard drive for them to download that data onto. That's what we had to do in Oregon for a long time. And the other problem with some LiDAR data collections, and this is more of a kind of an older problem and less so with newer data collections, but some of these LiDAR data and some of these elevation data may come as what we call fixed products. So it may be a LiDAR data collection, but there's only raster data available. The point cloud data, the raw point cloud data might not be available for those collections. And usually this has to do with just how much the state or the agency paid the contractor to collect that data and how much processing they did. And again, that was kind of an old business model. The newer business model, most states recognize that the point cloud data is invaluable for any and all projects. And so usually the point cloud data are available for those. So just to give you an idea of kind of state portals, if we go to the Iowa Geodata site here, okay, so this is the state of Iowa's OpenGIS data portal. We can search for elevation data. Okay, and this will give us a list of data that's available, that the state has available, or the state knows of, that we can get access to. And so here's 3 meter digital elevation data for Iowa. And so that's actually derived from the 2009 LiDAR data. If we go down further, there's things like a hydro-conditioned and hydro-enforced DEM. So that's for hydrologic modeling specifically. You can actually get bathymetry for selected lakes in Iowa, 1 meter hillshades. So already hillshaded data at the county level. So that can be actually it's broken up by county. 2-foot contours, so that's from probably the USGS contour or the USGS topographic maps. So you get the idea that these data are available here. And again, even if they're not directly available from this site, they usually will link to the place that you can get it. So, as you guys saw, some states have kind of other digital elevation model products available through those sites. And for the most part, a lot of those are derived from USGS data, which we'll talk about in just a second. So, nationwide data that's been collected, but it's just been clipped down to either the state or individual counties. The problem with some of these data that are available from the states is a lot of them may be reprojected. So we like to reproject our data into UTM because it's a nice clean projection for analysis. But the problem with a lot of the state level data is that sometimes, and less so anymore, but it's still very common in a lot of states, is that it may be reprojected into state plane coordinates, specifically for engineering projects. And state plane in most of the US is in feet. And so that's kind of stupid for a lot of the tasks that we want to do. A lot of the data that we have for other from other collections and other applications is all in metric. And so state plane being in feet, both for its horizontal coordinates and its vertical coordinates, really is a kind of a pain in the butt generally. Like I said, that's generally being phased out in a lot of states, but some states are still very strict about keeping stuff in state plane coordinates. So be aware of that if you're downloading stuff in other states, is that it can be in feet. So always check your projections. State departments of transportation do have some data. Again, a lot of this comes from road surveys or culverts or bridge engineering projects. Sometimes it's associated with rivers. Some states kind of put streams under the DOT versus the DNR. But again, a lot of those data are kind of hard to get. A lot of times, again, like the local scale data, it's collected by contractors, and the state doesn't really have it, or it's not really kind of publicly available. The one thing that state DOTs usually provide, though, which is good, is that they actually have most state DOTs have established GPS base station networks. So we talked about doing RTK GPS surveying. And so a lot of state DOTs have base station networks that you can tap into to do high precision surveys. And then a lot of state DOTs also kind of catalog and produce we call the geodetic points. So the benchmarks that we use for a lot of surveying are usually kind of administered by the DOTs in most states. So at the national and federal level, the USGS in the case of terrain data and most GIS data is king. The USGS has been kind of designated as the GIS data repository and collector for the US. And most of that data has now been kind of centralized in what's called the national map, all of GIS data in general. And specifically, terrain data is being collected and kind of organized under what's called the 3D EP, the 3D Elevation Project. And so you guys are going to look at that actually a little bit more in depth in Lab 2 for the next week. But the national map, if you're not familiar with it, is, again, the kind of go-to place for most GIS data. And so there's kind of two sides of the national map. One is just the viewer. So we can go in and actually view these data. And this is just an ArcGIS online portal. And so you can zoom in and add layers. So you can look at things like transportation and government unit boundaries and watershed boundary data sets, national land cover data. Here's some 3D EP data. So this is the elevation products. You can look up aerial imagery as well through this site. And so the USGS national map, the viewer at least, is useful as kind of a visualization tool. But what you guys will be looking at in lab is specifically the data download kind of side of the national map. And so in this, we can actually find all the different data sets that are available here. So things like USGS topo maps, boundary data sets, so state, county, census tracts, congressional districts are all under the boundaries. The thing that we're most after in this class is elevation products here, or elevation source data. So this is LiDAR data, point clouds specifically. I'll show you a different spot that we usually go for LiDAR data. You can download the hydrography. So this is the National Hydrologic Data Sets, imagery, map indices, lots of different data sets in here. And so you guys will be playing with this for Lab 2, just finding some data sets and learning how to download. But this is kind of the USGS main outlet for GIS data now, currently. Other U.S. or other federal agencies that collect data are groups like NOAA, so the National Oceanic and Atmospheric Administration. So they collect a lot of data in coastal areas, and so they do a lot of lidar and bathymetry surveying, so near shore and offshore. Um, and a lot of those data are available directly from NOAA. Some of those data have been started to fold into the USGS framework. But NOAA still kind of keeps hold of a lot of that data. So you may be able to find specific data from NOAA that you can't find from the USGS. NASA does a lot of data collection as well, but usually in partnership with USGS or NOAA. And so those data usually don't end up on NASA's website. They usually end up with the USGS or NOAA for download. The Department of Agriculture does some GIS data collection, but mainly just imagery. So aerial photography, um, some elevation data, but again, just mostly the aerial photography. And again, most of that ends up being distributed through the USGS now. The other big kind of player in data collection is the Army Corps of Engineers. Um, Again, it is a division of the U.S. Army, so there is some data that is hard to get if you're not part of that organization. Some data is available online. Not a lot of it you can get to directly, unfortunately. Um, but those data do exist. So if you dig a little bit or can contact the right people, sometimes you can get a hold of those data. The last kind of federal level outlet for data is a website called Open Topography. And so Open Topography is a website that is actually was commissioned by the National Science Foundation as a data repository for all of the different LiDAR, terrestrial laser scanning data sets, and now photogrammetry data sets that are being collected that are being supported by federal funds through the National Science Foundation. And so in this site is mostly LiDAR data and super high resolution data sets. But you can see, like I said, you're gonna play with this a little bit in lab 2 this week. But just for the US, you can kind of get a feel for how many data sets are out there. So, the green data sets are actually data sets from the USGS. The red ones are what I call the open topography data set. So those are LiDAR data collections that have been supported by the National Science Foundation. And then there are some kind of blue dots in here that are what are called community data sets. So these are data sets that have been uploaded by university researchers or state DNR projects. And so this has become kind of a go-to repository for a lot of high resolution data sets. There is even global data on here. So New Zealand has actually partnered with Open Topography to become kind of a data repository for a lot of New Zealand's data. But there is a little bit of international data here, not a ton though. So on that note of international data, my best kind of advice for finding international terrain data is good luck. It's hit and miss all over the place. Some countries have USGS-like agencies that are central kind of repositories for GIS and terrain data. Others don't. Most don't, in fact. On that same note, some countries have, central data repositories, so places where you can look stuff up. Lots don't. Some of them are open and have free data downloads. A lot of them, actually cost money to download data or to get access to data. In some cases, if you're a citizen of that country or a university researcher in that country, you can get access to those data. If you're a foreign person trying to come in and get those data, they're going to charge you kind of through the roof for those data because they know it's worth something and it costs them money to collect. So they're going to charge you for it. And oftentimes it's not actually that good of a data set. So you do kind of have to be careful of that. It's worth looking in different countries. So you can search for a country in LiDAR data, or a country in DEM data, or a country in GIS data more generally. And, you know, there are websites out there that have data sets on them that are produced kind of in a kind of community framework. So things like OpenStreetMap is a good example of community kind of contributed data, but there are other websites out there too that may have something that you need out there. But it's international data is really hit and miss. We're actually very lucky in the U.S. to have such a kind of consolidated, open GIS kind of data framework. So luckily, though, there are global data sets available for terrain data, and they're actually getting to be pretty good resolution. So again, the one that we talked about on Tuesday was the satellite radar topography mission. So the SRTM data that was collected by NASA now is kind of has its home in the USGS, and this globally is available between 30 and 90 meters, depending on where on the globe you are. Another data set that's been kind of continuously updated and improved is what's called the ASTER GDEM, so Global DEM. And that's a partnership between NASA and the government of Japan. And that is available at 30 meters. JAXA, the Japanese Space Agency, also has another, what they call a global digital surface model at 30-meter resolution. One key with a lot of these global data sets is that they don't actually cover the entire globe. And one thing that's kind of come out of that is that the Arctic regions of the world have been kind of left out. So things like SRTM actually only goes up to like 80 degrees north and south. And so there's kind of missing data sets in the Arctic regions. And so one thing that's been done recently through a group at the University of Minnesota and others worldwide is to create what's called the Arctic DEM. So this is actually a specific data set that's for the Arctic regions of the world. There's lots of actually global data sets out there. The next one is the kind of collaboration between NASA and the National Geospatial Intelligence Agency, NGA, to create what's called the Global Multi-Resolution Terrain Elevation Data Set, GMTED. And that one is kind of a combination of SRTM and ASTER and some other data sets and some covert spy shit to actually create kind of a better data set for the world. And that one's being, again, consistently updated. Another data set that's kind of that's interesting and kind of as a long-term data set is NASA has what's called IceSat, which is a space-based LiDAR specifically for measuring kind of ice sheets, so in the Antarctic and in the Arctic. And so that's another kind of source of global data sets as well. So lab 2 for this week is actually going to be no actual GIS for your part, so you won't actually have to open QGIS. But basically what you're going to be doing is kind of learning how to use the national map, which we'll use again in lab 4, and then learning about open topography, which we'll be using for our next lab 3, next week. So Lab 2 is available on Blackboard. Go ahead and download it. It's basically just a series of kind of instructions on how to go through the national map, answer some questions, go through open topography, and answer some questions. So if you have questions about Lab 2, again, feel free to email me or sign up for office hours through the link on Blackboard, and we'll get you going on that. So, nice short lecture for today. Have a good snowy day off.